Okay, now let's look at indexing. Okay, that is locating a particular place in the n-dimensional array and retrieving the content or the occupant of that location. Okay, so that's indexing. So as in Python, the indexing starts with 0, okay, and then 1, 2, 3, and so on. And here, the first dimension is called axis 0. The second dimension is axis 1, and so on. So it's a little simplistic, but you can think of it in this fashion. For 2 dimension, you can think of it as a table with rows being the first dimension, axis 0, and columns being the second dimension. So within the first dimension, this is the first element, and within that first element you have 0, 1, 2 in axis 1. Okay, so this position is 0, 0, 0, 1, 0, 2, and so on. Okay, so let's look at array 2 dimension. The array, again, same thing. Okay, so we have a NumPy array, a 2-dimensional array. First dimension, we have 3 lists. Okay, so this is the first element, second element, third element. Then if you drill down into the next dimension, in the first element you have these 3 numbers, second element you have these 3 numbers, and so on. Okay, so if you want to access a particular value, you can specify the location. Okay, so this is a 2-dimensional array. So first number will correspond with the first dimension. Second number will correspond with the second dimension. So if I say 1, 2, then it will, first dimension, it will go to index value of 1, which is that. And in the second dimension, it will go to the second index of 2, which is this. Okay, so that will be 6. Now if I give just one number, okay, and that would be understood as corresponding with the first dimension. Okay, so first dimension index equal to 2, which means 0, 1, 2. The third element is what is retrieved in that indexing. Okay, now if you do this, okay, so for the first dimension, okay, if you want to retrieve items from the second dimension, then you have to first say which of the first dimension you want to retrieve from. So you cannot go to the second dimension skipping the first dimension. Okay, so first dimension, that's the entry point. You already have the first dimension. So if you specify a number, it will just valid index number, then it will go to that index and it will give you the whole thing. If you want to drill down to the second dimension, then you have to specify which element from the first dimension you want to drill down. The colon here simply means everything in that dimension. So you're going to go to all the elements of the first dimension. So it will be that, that, and that. And from the second dimension, we want index 1. So index 1 is that. So index 1, all elements from the first dimension, so 2, 5, and 8. Okay. All right. So now we did this in list way back, where we can specify a colon. So suppose if we say we want colon 1. Okay, so again, since there is no other numbers here, this is your first dimension. Okay. Colon here, we are starting out with colon, so that means we start from 0. And we go all the way up to the number specified. But remember, the number that you specified is not included. Left side is inclusive, right side is not inclusive. So you have to remember that. Okay, I have to do ARR 2D. So it's the first dimension. Okay, everything starting from 0 up to 1, not including 1. So it gives you just the first element. That's it. Okay, ARR 2D. Okay. Then suppose if you say 2 colon. So that means starting from 2, everything below it. So there is only 2. 2 is the largest, so it's going to give you only 2, which will be 7, 8, 9. And suppose we say colon 1. So that means, well, let's make it colon 2. So it's going to give you what? 7 and 8. Okay. So everything from 0 up to 2, but not including 2. Okay. All right, so now let's see what this will give us. Colon 2, so that means everything starting from 0 up to 2, but not including 2. So which means these 2 elements. Okay, 2 is not included. And from that, we want 1 colon. So starting from 1, now remember left side is inclusive. So starting from 1, everything after that. So it'll be, you leave out the 0 position, so you get 2, 3, 5, 6.